Hello! So I have never recorded a voiceover before. I'm really hoping this is going to work. Last lesson we learned about our body's defences against pathogens. Can you remember any of them? Pause the video here and jot some down. The types of defences were physical and chemical. In physical we've got skin, cilia and mucus. And then chemical, we have got lysozymes and we've got hydrochloric acid. These barriers are great. They protect us from loads of diseases. But if pathogens are able to pass these barriers, that's when we get ill. So in this case, we have to rely on our specific immune system to make us feel better. We're going to learn how the specific immune system fights off pathogens once they've entered our body. But before we do that, there's a couple of bits of information I need to tell you first. To begin, here is a pathogen. I've chosen bacteria, but it could be any of the four we've learned about so far. On their surface, they have little proteins that are called antigens, and these are found on pathogen cells and our cells. These are really important because they're what allows our immune system to be able to recognise our cells as our cells, so it doesn't attack them, but it's able to recognise that pathogens are foreign cells, and so it will attack those. The way this works is that cells of our immune system produce more proteins, but these ones are called antibodies. Antibodies come in lots of different shapes, and the crucial thing here is that the antibody will only bind to an antigen that is the complementary shape for it, as you can see here. So antibodies only bind to antigens of a complementary shape. It's kind of think along the lines of enzymes having active sites that can only bind to a substrate of the correct shape. In Year 9, you learned about two cells of the immune system. One was phagocytes and one was lymphocytes. So phagocytes are the ones that engulf and destroy pathogens. They kind of swallow them up and break them down. And the other ones are lymphocytes. These are the ones that we're interested in today because these are the ones that produce the antibodies. And the significance of producing antibodies that bind to an antigen is that when the antibodies bind to an antigen, this signals for the pathogen to be destroyed. Now it's time for the specific immune system story. Here is our pathogen again with its antigens. The first thing that needs to happen is we need to actually be exposed to the pathogen. So the pathogen needs to get past our physical defences and our chemical defences and find its way into our bloodstream. Now we need the help of lymphocytes. So lymphocytes are those white blood cells that produce antibodies. And they exist in our bloodstream naturally, and we have lots of different lymphocytes that have lots of different antibodies of lots of different shapes. The lymphocyte that has the antibody, that is a shape that matches the antigen on the invading pathogen, will be able to bind to the invading pathogen, which causes that lymphocyte to become activated. The lymphocytes that have the wrong-shaped antibodies will just continue on their merry way. Nothing will really happen to these this time, but the lymphocyte that's been activated will grow and divide and make lots and lots and lots of identical copies of itself. So now we'll have lots of lymphocytes that have the antibodies that are the correct shape to bind to the antigens on the pathogen. Now we have lots of these lymphocytes, one of two things will happen to them. The first thing that could happen is that some of the lymphocytes will secrete, which just means release, some will release lots of antibodies, which will bind to the antigens on the pathogen, which will destroy the pathogen. The other option is some of these lymphocytes will remain in the bloodstream, and these are called memory lymphocytes. You must remember in an exam to call them memory lymphocytes because memory is often underlined in a mark scheme. These memory lymphocytes would be able to respond so quickly if you were infected by the same pathogen a second time, you wouldn't even feel ill. This is how you become immune. We lastly need to look at this graph. Perhaps pause the video for a moment and try and understand it for yourself. So along the x-axis at the bottom we have time in days, and on the y-axis up the side we've got antibody numbers per centimetres cubed of blood. You'll notice along the bottom we've got 0 days, 10 days, 20 days, then there's a little gap for a moment, and then it picks back up again at 100 days onto 110 days, and so on. The first infection with the pathogen happens at about 1.5 days. Then there's quite a long period of time where antibody numbers in the blood actually don't change. During this time, we've been exposed to the pathogen. However, it takes some time for the correct lymphocyte that has the correct antibodies to bind to the pathogen's antigens to actually come into contact with the pathogen and be activated in the first place. Then we see a slow and steady increase in antibody numbers. So this must mean the correct lymphocyte has been activated and it's growing and dividing and growing and dividing. So there's more and more antibodies present in the bloodstream. Here, the lymphocytes are producing antibodies which are binding to the antigens on the pathogens and destroying it. So we're fighting off the pathogen here. The numbers of antibodies start to reduce once all of the pathogens have been destroyed. Well done if you noticed that when the number of antibodies starts to reduce, it doesn't get as low as the number it was at the start. The reason for this is that at the start we maybe had one lymphocyte that had the correctly shaped antibodies for the antigens on this particular pathogen, whereas now lots of memory lymphocytes have remained in the bloodstream which all have the correctly shaped antibodies. Our body has now responded to this pathogen for the first time, so we call this the primary response. And some time is now going to pass until a potential second infection of the same pathogen. When this second infection happens, notice how we have a very steep increase in antibody numbers. They get much higher than they were in our primary response, and it happens much, much faster. The reason for the rapid increase in antibody numbers this time is again to do with those memory lymphocytes that stay in the bloodstream. So we don't have to wait around for that one lymphocyte to be activated like we did upon first infection. This time there's a few memory lymphocytes that have already been activated once and they are already able to make the correct shaped antibodies. It's thanks to this rapid response of memory lymphocytes that you don't feel ill if you were to be infected by the same pathogen for a second time. When this happens, you are immune. That's it. Watch this video as many times as you need to.